All right. So, part 3, the Sidecar Supervisor thing that I'm working on, which is sort of a specialized supervisor for Sidecar Processes, things like plugins, etc. Built as a component library, or a library is a component. And last 2 parts kind of just getting set up and getting testing and research and stuff like that. I think we're actually going to get into the meat of it this time. So we'll be listening to Celeste here, which is a great game. I recommend it. Also great soundtrack by Lena Raine. So, let me make sure chat's working. Feel free to ask any questions related to this, or what I'm doing, or anything at all. Or tell me that I need to turn down the music. So let me ease back into this. We've got our line writer. Let's not start there. We've got our process. So this is the sidecar process. So we're wrapping up an exec command. We're using a circular buffer to store recent logs, so that when it crashes, we can write that to disk. As a name, I'm not sure that's relevant. I take that out. And for the most part, we just start a process. It takes a line writer, and so the way line writer works is basically a little micro line log aggregator, because you want to interlace your lines without them cutting into each other, so you can't just give all your subprocesses access to standard out. And then we also kind of format them and give them identification so that we can kind of see whose logs are whose. And so that's the line writer's business. We start stuff up. We have some signal stuff. And then we just started working on the supervisor, which is going to set them up and ultimately reload them, and either the supervisor or some other, the client or the user of supervisor can then watch the file system to reload those, so we can get a tight development feedback loop. And so yeah, I've just kind of slowly been going along, making sure we get tests in here as we go. Some basic tests here, just testing our start process with the line writer, just making sure that we get standard out, that we get standard error, that if we get a start error, what is this? And the way we're testing these, if you missed previously, this is basically how the exec command is tested in the standard library. You create a special test that's entered into when you actually want to run something. So when you run something, you actually use helper command, which basically replaces what you want to run with this process and this flag saying to run that test. And then we do our simple arg parsing to find out what we want to run. And so these are sort of mocked commands. So we're not testing anything beyond really the basics of what we have set up here. But we did also start creating a little bit of helper stuff because our output, our line writer basically spits out the name and some padding, and then a divider depending on whether it's standard error or standard out, and then their output text. If we wanted, if this was for like something around a server and some infrastructure and you wanted structured output, you would just log that directly. This is more for, at least for now, running on the desktop, so I don't really care. But we do have to parse that to test, and it's kind of obnoxious doing that all the time. So we have this kind of a line parser that just does basic splits and gives us a line object with the header, the message, and whether or not it's standard error. And then we have this parse lines. So now we can kind of process the output that we get from line writer into a buffer, and then parse those lines and test them easily. So far, so good. Now we're starting to get into the supervisor. The main thing that we want to do is be able to reload, which will also start processes. So let's see, what were we doing? We've got our sidecars in a map. We can look them up by their full path name. If the process is there, then we're gonna kill it and wait for it to finish. And then this is a little presumptuous. Maybe this should actually be in this if statement, because this is basically copying the values of the previous P's command. And then we start that up. Like we take finished. So a lot of this is where stuff gets interesting, and I don't remember where it was going last time, so but I definitely can't do this, because if it's not in sidecars, then we'd have to figure all this stuff out. So this one's pretty easy. Path, there's no arguments. Let me check our helper. We might need to replace this with something that yeah. We'll see when we need to test this, what we have to do. Environment, we're actually gonna copy from this process's environment. Its working directory will be the directory of the thing that we're running. Yeah, Yeah, I think I was just copying and pasting where I've done this before, where I restart a process, because you don't want to just use the same exact worker. I'm throwing the old one away and creating a new one. So it would seem, though, that we actually want to start something like this. Line writer. Got the line writer. I don't think we need to set any of this. Start process is going to set all that up. Finished. So we're modeling this using as a reference for Go. But we're kind of setting things up a little bit differently here. When we start this process, okay, we close finished. So actually we would start a Go routine that waits for finished and then calls reload again. Looks like got a mutex. It's probably a good place to lock it up. Finished. Do we have finished? We don't, so make a channel of OT struct. Oh, this is a function. And I guess, let's see here. Try not to think too far ahead and just kind of go one step at a time. So we have finished, or we have whether it was terminated. So let's come back to that because we're not really handling that. So here we'll just wait for finished. I'm actually gonna sleep just for like 1/2 a second. milliseconds. Is it not telling me what time has because it hasn't been imported? And we'll come back to that. But we'll basically want to say s reload path. So what's the problem here? Multiple value. Okay. Do we do multiple values? Yes. What do we... Where's the error? I guess if start errors. So in theory, so could error. So could reload. So this is where start process. We might want to track this at some point. Wait group. Trying to get in the habit of sort of what is it called in Erlang when you attach a parent or something? I forget. I remember using it a lot with G-Event. Could link processes. Now I'm trying to figure out how to test this. So there's a problem where we need to override this, and so I'm thinking maybe Supervisor has some kind of command factory or something. Yeah. Let's see, given a path. Thing is, though, we have things that we want to set and then have them changed. It's almost like we want this to go through a filter. So I don't know how common this is for doing, testing things. Usually we do something like pass in a factory, but I guess our factory could take in a value, and we could do path. I don't know. Somebody's gonna have to tell me if there's a better way to do this, because I can't really think of one, but So this could be nil. And then we'll just define one right here by default. Let's see, I'm guessing we don't care. Just maybe return this. So it's basically pass through. How we'll use it here. Let's see. So if we were to say command factory. Whoops. So our helper command should take this factory API. Let's see. And probably want to do something like this where helper command path, which takes a string, and then that I'll call helper command, where we pass in a command with path. I mean, I guess we don't care about arguments for now. That's kind of interesting, but yes, and then path. I'm guessing we actually want to append this, because if environment's set. So I don't know why they named this. Maybe this is something that I deleted. I'll call this command. Return command. And here we'll set the path to this arg0 and set the args to we'll just append it. Although I think it's a pointer to it's OS exec, isn't it? I mean it's a slice, so I think you can just always append to it, right? We'll just do that. We'll do that. Let me double check. That's not good to find out. Oh, no. There we go. So, okay. Good. Good then. S? No, what is it not like? Because it's not. Path is up. Because we're getting a bunch of them, so we can do args. We can do that, right? It's not complaining about that, it's complaining about other stuff. Now I have to replace this usage everywhere. Okay, what? Interesting. How's test process now? Did I do this right? Should not be running test process standard out. Test process standard out. And I'm not even Okay, what am I doing? Command path? No, I don't want to do that. No, I do. And I actually want to append, probably, even though I'm not using them here. Why are these running? Process standard out. Show me what this command looks like. Yeah, shouldn't that work? Did I totally change this? How was it supposed to work? Maybe I fucked it up. say, hey, args, that's a path, and then that's args. Well, that's not this. Oh, this is the only one that we're doing that for. Yeah, I don't understand. This should be running that command and test run helper process. We can put it back. It wants command to be defined. I mean, fucking, I could have just done this. Right, S. S would be our command args. What's the problem? Oh. So sure, we'll just set a new one. Why not? No command. Okay, so it's running. This isn't any different, is it? Oh, because args needs. Okay, that's the difference. Path. Different languages do this differently. When you do args, it needs to include the arg0. Fuck. Okay. Easy. Which is actually more aligned with what the underlying call is doing. So we got path here. Oh. Oh. It's because command is doing that when you use this constructor. But because we're doing this. Okay. Then we want to do this. Got no command. That's not right, is it? Because we're not setting any args. Oh, yeah. Oh, that's what we do want it. Kind of confusing. There we go. Okay, so now back here, our supervisor test. We can do something like command factory equals helper command. Good, that has the same signature. Everything's cool. Supervisor here. Start process. Let's see, so maybe we'll call it reload path. Standard out, I guess, to test this. So we've got a new supervisor. We can now do standard out. Problem is, of course, this is going to, it's going to exit, and then it's just going to do the same thing. Though this gets us to the fact that we do want to only retry like 3 times. I'm not sure. We can't pass it recursively. We could keep state on supervisor, but I would say we could put on process, but we create a new process every time. And then how do you reset that value? So one idea is to have a sort of internal reload that takes some like a retries int. If retries is greater than or equal to 2. And here we can reload and we increment retries, pass retries. And then we create, you know, the public version of this, which is so. We should be able to look at the buffer. Let's reload. This is where wait groups comes in, because we need our supervisor to wait. So we will go back and look at how they're doing this. No. Oh, wait, no, we do want start. Let's see, so ultimately so we can put wait group on our supervisor. Which means, let's see. Here we can wait group, add one. And defer wait group done. Actually, that's S wait group done. Test supervisor. So, supervisor also needs a wait for that. So we can do that. I think we can call this whatever, that's fine. So here we'll wait just to make sure that it runs and finishes. It takes a while because we do have that hard-coded delay here. So we can build that in to this as a restart delay. Let's see, maybe the default is 500 like we had. needs to be a duration. Fancy. What do we do here? Just the same thing? Oh, I did 500 millisecond time. Okay, that's not gonna work. Stop. So, now that's a duration. We will call it milliseconds. Okay. What's all this? Is this from before? We'll see. Let's see, we can do our test. Now we can lower this. I think we can actually set it to 0. And just to see that what we're working with here, we've got. Oh, we need a quick way to get access to that. Function supervisor logs, which will give us a byte slice, I think. Logs. Are we teeing to that? Okay, we are teeing to that. Okay, so we want or I guess if not, okay, we'll give them some empty bytes. But actually, I'm not sure that this gives us. Oh, it does gives us bytes. Perfect. We'll do that. Does this also reset it? Oh, we throw it away. So that's. No, I think this makes sense. This makes the most sense. So. We can look at our logs. Logs. Sting it out. Okay, so that's the logs. That's actually not what we were checking. We actually have this buffer. This is what we wanted. This is what we wanted. We didn't even need to make logs, but now we have it. We want this, which is going to give us 3 outputs. So that's right. Let's see. So actually, this is what let's do parse lines. Lines. Nope. Can't use this type buffer. It's actually doing, because they're stringers, that's why it looks like that. But let's see. But so far it's kind of working. So we can actually put number of retries in here. Two. Retries. Sure, we can call it retries. And so now on our test, we can actually change this to 3, and then we'd see more of them. We change it to 1. Of course, one restart means it runs it twice. So we're kind of using our test to write the stuff. This is the final test. I don't even know what we should be testing, but I'm just thinking now about functionality. I'm using this to sort of push through what it should be doing, and then figure out exactly what to test. Because I feel like otherwise I'm going to write a bunch of tests that aren't necessary or weird or whatever. So, coming back to what do we want it to do? Basically, we tell it to run something. Let's see if I wrote this down. On unexpected exit. So, how do we know what an unexpected exit is? We could define an unexpected exit as any exit that wasn't by us. Because we expect the ones that we do. We could say unexpected error exit, which would be anytime it exits non-zero. Or maybe this is kind of unrelated, where like any unexpected exit, even if it is exit 0, it will try to restart it for however many times it's configured to restart it, because its job is to just make sure these things are running. But we have the failsafe of like, oh, it can't restart, you know, it dies after being restarted twice. wait for some other input, like the file being changed or something like that. And then maybe it only writes the log file when it is a non-zero exit. Which is good, because you shouldn't be writing programs that, it's an error and it exits 0. So now I have to think about the file system stuff. Let's get file system abstraction here. We all use this, right? Is this in the standard library yet? File system, new OS file system. Perfect. So, sorry, my brain is in web dev mode, so I'm not sure if it's the same thing that I'm working with. Web dev, maybe. I'm generalizing. A supervisor is something that watches other processes and makes sure they're doing what they're supposed to, which is usually running. When most people think of supervisors, they think of an init process, which is the first process in a Unix system or Linux system that will then run every other process and then make sure that they are running if they're supposed to be. There are supervisors made to run multiple processes for like a cluster of web servers. So in that case, it's not the init process, it's just another process that is running multiple processes. Then there's supervisors. To me, there's special supervisors that I would write for Docker containers, where I want, instead of just trying to restart them all, I want, if any of them die, I'm going to kill all of them, which is a common pattern in kind of Erlang process management, but not typical for what people call supervisors. But this supervisor is totally different. Let's see, that was cut off. Supervisor, the software. Do you mean supervisor D? It's a Python thing that manages processes. Yeah. That's I guess the most popular one that is not an init process. However, this one is slightly different from all of those because this isn't made to run other processes just to run other processes. This is running other processes that typically plug into the host process. And so in that case, we have slightly different behavior, but I call those sidecar processes or co-processes. So this is less a tool and more a component that you'd use in a system that needs to run other processes and extend the functionality or provide functionality to the host process. So because of that, we have all kinds of things that we don't care about that normally supervisors would care about, like well, it really depends on how you operate your systems, but instead of trying to get things to restart or have like a back off and then failing, we retry a couple of times and then we give up, but we let the others run because we assume that if it crashed, then we take that crash and write it to a log file so that you can go and fix it and reload it, and the application can continue running and the other plugins can keep running, and then that particular plugin will be replaced once it's fixed. So this is definitely a unique case, but it is the general idea of supervisors managing processes. So I think I was about to add a new let's see, the file system abstraction. So supervisor is going to need to have a file system to work with, and we want to be able to mock that out. So we're abstracting it with an Affero file system. Can we do FS? Is that an interface? Cool. And by default, we'll do Affero new OS file. Oh, new OS file system. And let's see, in our test here though, we'll create a file system based on just a memory map. And let's see, finished. You know, maybe we actually want this to check the exit status and then pass that to finished. Let's see, but we're doing a close. We're using a close pattern to signal. But I guess that's fine. Yeah, that should, no. It means we're always going to send 0 or 1 or whatever. So we won't close it. I don't think we need to close them. Do you need to close? Golang, need to close? I don't think so. Channels? Yep. Yeah. So we're only using this as a signal. Oh man, checking the exit status. Right, that was a lot of work. One of these did that. One of these. I think it was when I was looking at Plan Archive, get receipt. I've got a nice little function in here that I used to use a lot. Alright. So actually we don't want the exit status message. We'll just take a uint. How about an int? Guess we're just saying 0 here. What happens if there's an error? Panic. Alright. Yeah, finished. So we're assuming finished is optional. That's fine for now, I guess. Let's see, what does wait give us? How do we activate help here? Okay. So an error. So, finished is passed in here. It's now channel int. It's fine. Finished. Take me there. Yep, needs to be an int, I understand. I'll call this exited. More clear. What's this? Oh, another one, yeah. Exited. Alright, where we're using finished. Right in front of me. Oh, you can't call wait again. Why am I calling it twice? What are we doing here? Command wait. Oh, I see. This was back when we didn't have this implemented. So we'll have to do that now instead. Which is, you know, more to set up, but I mean, in theory, it could just return it because it doesn't really matter what it is. We don't really want... I've gotten in a habit of passing channels in that are going to be used to return stuff. Just because, in theory, there are cases where the user wants to define whether it's buffered or not, but there are a lot of patterns and stuff where I think it is you know, it wouldn't make sense to buffer or not buffer. So I think I'm going to make start process return a finished channel. Or, because it returns process, and this is all internal, we can just have a exited channel here. That seems pretty good. And create a new. Ah, here we go. Feeling pretty good. All right, what's this? So the, oh, because we wanted to optionally define this. Because if it's nil, then we can avoid sending on it. And we can just say that you should receive on it. I could even wrap it up in a wait if we really wanted to, but so we're gonna no, as P exited, and it's always defined, so we will always write to it. How's that? And then, what is the problem here? Too many arguments. So we update our tests. We can get rid of this. We can... Oh, did we return it? I don't think we did. Oh, we're not returning. We're accessing it on P. So we would say P exited. Get that P. Fix this up. Alrighty, this is nice. Do we care about this? I guess we don't. Oh boy. I'm gonna take a phone call. Hello? Hey. How's it going? How's the meat? Oh man. Sorry about that. We've got like 40 minutes left. So let's keep going. This is fine, I think. And then what's all this nonsense? Alright, so then it's supervisor we need to update. Exited. Interesting. Hopefully this doesn't bite me in the ass. P declared not used. Where's that? Oh, yeah. Alright. Okay, so now we have this file system nonsense set up. Which I guess means we can start thinking about writing to it, right? Oh, and that's why we set all this up, so that we can get the code. I'm guessing if it's closed, it returns a 0 value. I think that's what I recall. Luckily, 0 is not a value we care about. So, General J-Man, how's it going? Welcome. Let's see, are you a Go programmer? Also, thanks for following. It helps with my little follower goal there. Also, check out my schedule, my events. I have either look at events or look at the schedule on the channel page because I stream different stuff. And there's actually follow buttons for all the Go stuff. So if you're interested in Go, you can just follow the Go streams. I'm guessing we just want to append to a file. Let's see, if an exit is non-zero. Yeah, I guess we'll append to it. So worst case, we have the same output in this file several times because it tried to restart it. So let's see. Maybe we can wrap that up here into something like dump logs. This is happening inside. No, so that would need protection. So if status is greater than 0, then dump logs. I mean, really though, we should pass this reference, because if the mapping changes because it restarts, right? Because it reloads, so we should really send this specific one. So we'll dump the logs for this particular process instance. So this then takes not logs. Dump logs now takes process. Forgot what we're doing. And then it might return an error. We might want to, I'll put it there. We'll see. This is kind of more of a subroutine, so let's see. F. Do we have just a write open file? Let's see. I think we have some top level helpers that are pretty convenient. Write file. File name, data, file mode. We do append. Yeah, append. Let's see. What am I looking for? I was gonna look at go file path. Go file path. Because wasn't there something that removed this suffix? Oh, thanks. Did I do something in particular to deserve that, or are you just playing with the buttons? See, this is oh, which stuff on YouTube? I guess these videos, right? Maybe you're seeing some of the earlier parts of this. Now you're joining, unless you're talking about some other Golang YouTube videos. I guess I did make some from a while ago. Oh, the devlog for Indie Game Legend. Yeah. Cool. Yeah, man. It's not hard to become #1. My friend Andy likes to dump those in there, but he's usually #1. Not this week, though. So I'm kind of frustrated. How do people trim the extension? See, really? This is what I find kind of obnoxious, but fine. I'll do that. So process. Shit. Oh no, I guess path is what we want. That's gonna dump them in an unexpected place in the tests. Interesting. Actually, maybe not. Our helper, we can use this yes. ArgCS path. Yes, it'll work. That's awesome. So path or arg0, arg0. Yeah, that'll get us what we want. And this is arg0. Oh, this is getting ugly. I don't know why people too far equals, but whatever, fine. I guess that's kind of a as people are setting up variables, they'll be like, put it in a big var. But what's the problem? Name. Declared not used. Right. So, actually path. And actually log path. I don't know, as per def. Oh, we're almost to the end of today. Dot log. Error log? I guess just log. No, we don't want it to imply that it's a log you can look at. You know, regularly. This is a dump. What is npm or what does node call? Then when debug.log maybe? Or actually I think I'll call it that. Debug, because you're debugging why it crashed, and it's a log. That makes it pretty clear. Let's see, write file, SFS. process logs bytes. And then what is this? OS file or mode append. I don't know, man. Is there a way to debug these file systems? Like, print out a pretty tree of this file system. I don't see anything. It'd be nice. Oh. You have to do like a walk on it and do your own thing. Wham, wham. Let's see. I'm gonna write file. Assuming that's oh, just an error. Okay, that's nice. I'm just gonna panic at that errors for now, just to see what happens. So dump logs. If status is greater than 0, dump logs. Cool. So why don't we try testing it with exit non-zero. The fuck? I guess exit non-zero doesn't actually output anything. Maybe it should. Oh, it's actually helpful to have one that just does that. So let's make another one that does. How about we panic? Just a good old panic, and we'll say, I don't think we even need a message. We'll just panic. Okay, we do need a message. Panic. So let's try this. Let's make this thing panic. Did it not? Shouldn't. We should see the output of a panic, right? Where's the panic? Stops execution, calls panic, normal execution, stops immediately. Any functions whose execution is deferred are run the usual way. So called G, the invocation of F when N behaves like a call to panic, terminating G's execution, running in deferred. Right. This go continues until all functions in the executing go routine have stopped in reverse order. At that point, the program is terminated and the error condition is reported, including the value. This termination sequence is called panicking, can be controlled by built-in function recover. So why am I not getting any of that output? If I put it after, that shouldn't work. Right. So, can I do go run startup go test.run test helper process? Oh, so then how do I do a go test? And it's probably the same thing. I just need to say test. Go test. V. Oh, I need to set the environment. Want helper process. Unknown command foo. Cool, we're in. What happens when we panic? It just ends. Why is that? Because it's going through a test harness, and the test harness is capturing the panic. I guess that's what's going on. Why is it okay though? Why isn't this panic doing anything? when run as a test. Test run. Test okay. Test panic. Test okay. Get that. See, it should fail. What is going on? If I create a test that panics, it panics, right? Uh-huh. Panic. Is it this deferred? It's the deferred. Wow. Did not expect that. Can you undefer? Actually, you know what? I don't even need this. There. That should fix it. And we don't need this. And we get all that panic output. Perfect. Perfect. Okay. So now what I want to know is, did that write the file? Let's see. Write the file. Maybe I will. I'll just walk it. I don't know why I was so hesitant to use walk. Path, file info, error. Thanks, I don't need all that. Alright, show me what you got. Oh, okay, yep. Sorry about that. Panic debug log. That's what I was looking for. Let's see. Panic debug log. So it's actually a pretty predictable place. That's good. I was still thinking it was writing to its like test executable name, but not file path. Where are we? Read. Give me these bytes. Better not be an error. Hopefully there's something I can use here. Panic debug. And then flat print line. Just for fun. Oh, we don't get anything? Is there an error? No, I'll be nice, fatal. File does not exist. Why do I believe that? SFS. We just saw that it's writing that file. Oh. Is it trying to walk there and root doesn't exist or something? If you make a memfile. Oh, what are we doing here? Someone tell me how to do this. Everybody wants this. That's right, that's right. File does not exist. Okay, so it's not that. I feel like I've run into this before, but like, why doesn't it think it exists? Let's see, we don't have stat. Let's do walk again. Just expand it for me, please. Tab. Something cool. Alright. It's gotta be all. What is going on? Tell me what path you have, what info you have, what error you have. So that's weird. If is there no info? Yeah. Is it because I did something stupid over here? Okay. Nil doesn't have one. Skip it. Wait. So it doesn't have a name. I am so confused. That should write some files. Or a file. Why doesn't it have a stat or anything? Come on. No examples. This is supposed to be a good library. It's on 7. Didn't even get any kind of sense of completion here. So it prints out a file. I need to stop doing that. Prints out a file. Wait. That is the error. Is it? It's not something else. Fucking who cares? That is the error. File does not exist. If I don't print that, it doesn't say that. Okay, so interesting. Our supervisor thing here isn't returning an error though. Because it would panic, right? Unless anybody else has ideas, I'm gonna not dwell on this and wrap up the stream, and hopefully I'll figure it out before the next one, which would be on Thursday. So, thanks everybody for joining. There's a Discord server. You can see my schedule either in events or in the little schedule thingy on the, that's not the right title. I need to fix up my OBS. Yeah, there's a schedule. You can see what I'm streaming. I'm streaming game development. I'm streaming Go stuff. I stream Go stuff Tuesdays and Thursdays and Sundays. So if that's what you're interested in, click remind me on those events. And all these are published to YouTube, so you can go back and watch them on YouTube if you want to watch 2-hour-long coding sessions for some reason. Anyway, thanks everybody for joining. General G-Man, thanks for following and saying hi. See you later.